On this video, I'm going to teach you how to do the lattice method for multiplication. But first, let's start off doing a problem using the standard algorithm, or the way you normally use to do a multiplication problem. We're going to do a 3-digit by 3-digit problem. Let's do 29 times 12. So we're just going to do this problem how we would normally do it. So we do 2 times 9 is 18. Carry our 1. 2 times 2 is 4 plus 1 is 5. Then we do 2 times 1 is 2. Then we're going to multiply by the tens digit, which is a 1 there. So we have to put our 0 because we're multiplying by 10. Then we do 9 times 1, we get 9. And we do 1 times 2 is 2. And 1 times 1 is 1. Now we have to multiply by the hundreds column. For that, we have to put 2 zeros down. Then 1 times 9 is 9. 1 times 2 is 2. And 1 times 1 is 1. And then we just add straight down the columns. 8 plus 0 is 8. 5 plus 9 is going to give us 14. So we put the 4. We carry the 1. We have 9 plus 1 is 10, plus 2 is 12, plus 2 is 14. So we write the 4, we carry the 1. We have 2 plus 1, which is going to give us 4. And then we just have 1. So our answer is 14,448. Now that we've solved this problem using the standard algorithm, the way we're used to solving it, let's try a different method. The method that we're going to try is called the lattice method of multiplication. Once I get the problem set up, you'll understand why it's called that. But why would we use a different method, since we're so familiar with this one? It's because of this part right here. When we multiply by tens digit and by the hundreds digit, we have to remember to add in these 0 placeholders. If you miss those placeholder zeros, it throws your whole problem off and you have to go through and figure out what you did wrong. This method doesn't use the placeholder zeros, so it might save you a lot of time. So let's do the problem. We're going to write our first number, the number we normally write on top, across the top, but we're going to have it spaced out a little bit between the digits. Our bottom number, we're going to write down the side. Next, we're going to box out the problem, which just means we're going to make a line across and a line down. And then we're going to draw lines dividing each set of digits. So we're going to draw lines vertically and horizontally. If you're doing a 3-digit by 3-digit, this will end up looking like a tic-tac-toe board. Then we're going to make the lattice part, which is where it gets its name. We're going to start in the top right-hand corner of each box and draw a diagonal to the lower left-hand corner. Next, it's time to actually do your multiplication. With this kind of multiplication, we can start anywhere on the board. So let's just start here. 1 times 1 is 1. To write this, we're going to do our tens digit in the top part of the box and our ones digit in the bottom part of the box. Since 1 times 1 is 1, we don't have a tens digit, so we put 0. 1 times 1 is 1. Then we have 1. 2 times 1 which gives us 2. So we have 0 tens and 2 ones. We have 9 times 1, which gives us 9. Once again, we have 0 tens and 9 ones. Then we can just pick any other spot. We'll just move down to the next row. We have 1 times 1 is 1. So 0 tens and 1 1. 2 times 1 gives us 2, which is 0 tens and 2 ones. We have 9 times 1, which gives us 9, which is 0 tens and 9 ones. Then we have 1 times 2, which gives us 2, which is 0 tens and 2 ones. 2 times 2 gives us 4, is 0 tens and 4 ones. And finally, we have 9 times 2. 9 times 2 is 18, which is 1 10 and 8 ones. Now, how do we get an answer out of all this? Well, this is where those diagonals come in handy. Before, where we added down the columns, we're going to do the same, only we're going to add across the diagonals. So, this is just to kind of give you a visual of where we're going to be adding across. Okay, we have 8 plus nothing gives us 8. We have 9 plus 1 is 10, plus 4 gives us 14. So we write our 4 and we just make a 1 out here, just somewhere where we can see it. 9 and 1 gives us 10, plus 2 gives us 12, plus 2 more gives us 14. We carry our 1. We have 2 plus 0 and 0 is 2, plus 1 is 3, plus 1 is 4. And finally, we have 1 plus 0 gives us 1. And then we just have a 0 up here. But we know that if there's a 0 in front of a number, we just disregard it because it doesn't change anything unless there's a decimal point in front of that 0. So we read our answer down and then across. And that gives us 1, 4, 4, 4, and 8. So our answer is 14,448. You can double check this using your standard algorithm. We had 14,448 using our standard algorithm too. This is probably easier when you're doing the larger numbers or if you're easily confused by having to add those placeholder zeros in. You don't have to use it, but feel free to give it a try.